Hello friends, welcome to Tech Greens. So today we are starting with a new series for Hadoop tutorials. So this is the first video in this series. Today we'll look at the introduction. What exactly is Apache Hadoop? So guys, let's start. So guys, Apache Hadoop is a collection of open source software utilities to solve the problem of big data storage and processing. So Apache Hadoop is meant to facilitate the big data processing and storage, and it works on the concept of distributed computing, where this big data processing and storage will be done across multiple nodes in the cluster. So the load would be shared across by number of different nodes that will process the small amount of data in parallel, and eventually that all those results would be collated and the entire batch process would be completed. So if you can see in the picture here, Apache Hadoop is on the architecture lines of master slave. There would be one master node and rest of the nodes in the cluster would be the slave nodes, and all the data processing in the Apache Hadoop world will happen in parallel across all these slave nodes. Um, Another important factor about Apache Hadoop is based on the design principle that hardware failures are common occurrence. It is based on the fact that hardware failures are common occurrence and that framework should be robust enough to automatically handle this particular situation where one particular machine or one particular node is down. So this is also the definition of fault tolerance in the distributed world, and Apache Hadoop is absolutely fault tolerant, and it takes care of the machine failure automatically as part of the framework. And as we have already discussed, the entire data processing would happen in parallel across different nodes in the cluster. So guys, let's see the component architecture for Hadoop. So currently we have Hadoop 3 available as a general release, but the main difference when we look at the component architecture comes between Hadoop 1 and Hadoop 2. Hadoop 3, there are not major changes from the component architecture standpoint. So we look up what is the difference between Hadoop 1 and Hadoop 2 from the component architecture perspective. If you see Hadoop 1, it has one HDFS layer, which is the Hadoop distributed file system. And on top of that, it has a MapReduce layer, which is the programming paradigm provided by Hadoop to do the distributed data processing. And MapReduce in Hadoop 1 used to do the cluster resource management and data processing both. However, in Hadoop 2, if you see, there is introduced a new layer which is YARN. YARN stands for yet another resource negotiator. So this is the cluster manager, resource manager, and it facilitates the data processing through MapReduce. And also on this layer, other data processing engines can also be hooked upon. So primarily, if we talk in current system, Hadoop, we can say there are three layers. One is MapReduce, another one is YARN, and then the bottom one is the HDFS. So guys, let's see what are the different the components in the Apache Hadoop framework. The first one is the Hadoop Common. This includes the set of common libraries, utilities, software pieces, which are used across Hadoop modules to interact to do the underlying boilerplate processing, storage, etc. The important layer is the Hadoop distributed file system. It is the distributed storage provided by the Hadoop world, so that you can store your big data in the scale of petabytes and terabytes in the distributed way with HDFS. Uh, Next component in the line is Hadoop Yarn. As I've told, it introduced in Hadoop 2. It's responsible for managing the computing resources, scheduling of resources, and facilitating the data processing through the MapReduce. The next component is Hadoop MapReduce. Uh, it is an implementation of the MapReduce paradigm model, which is meant to do the data processing for large or big data systems. So these are primarily the four components of the Hadoop, Apache Hadoop framework. Guys, this is how at a high level, the architecture of Hadoop looks like. As we discussed in the previous slide as well, it's based on the master-slave uh, architecture. So there would be one master node. Any one of the node in the cluster would become master, and rest of the nodes would be slave. And as this works on the concept that here we don't make data travel to the code. On the other side, here the code travels to the data. So in the distributed way, data would be distributed or available in partitions to the different slave nodes in the system. And the code snippets to do the processing of that data would be sent across to the different nodes, as they will be smaller compared to the data if we talk about. And using this architecture, your code will work on the data on a particular node as a local data available. So that will enhance the overall speed of the data processing, and hence we'll get faster processing. So guys, let's try to understand how Hadoop computation works. As we have discussed, the way we store the data in the HDFS in the distributed way is your entire big data would be split into different smaller files, what we called uh, blocks, and these blocks would be available on the different nodes in the cluster and for processing. And then the master will transfer the package code to the different nodes meant for the processing of data available on those nodes. So here we are using this approach. One thing is we have saved the network bandwidth, we saved the network overheads because we're not making data to travel over the network. However, we're making code snippets to travel over the network, and code snippets are comparatively smaller, very smaller to the big data, petabytes and terabytes of data we're talking about. Uh, this allows the processing of the entire data set much more faster, because all the processing would happen in parallel. So that will also increase the overall throughput of the entire system. So guys, this is at high level how Hadoop computation works. The code snippets are packaged and transferred to the different slaves, and data is locally available. Different blocks or partitions of data are available, and then that code processing happens, and it happens in parallel, and eventually the entire process is uh, is working in a distributed way, and it works on the design concept of horizontal scalability. Any point in time you can add more nodes in the cluster if your peaked if your data is so huge and you require more resources for your computation. uh, and there would not be and these all slave machines are simple commodity hardwares, so that makes it much more cost effective, economical, and at the same time the entire Apache Hadoop system is absolutely fault tolerant. So guys, that's it in this particular video. Keep watching this series on Hadoop tutorial. Have a good day. Bye bye.